Okay, in this section 3-24, we're looking at scatter plots and different types of correlations among some other things here. And so the first thing that we come to are some examples of different types of scatter plots. And so what these graphs illustrate are the different types of correlations that you can have. So we'll title this Types of Correlations. Okay. And so there's really three categories of correlations. So if they generally go upward from left to right, then we'll say that that is a positive correlation. If the scatter plots dots generally go down from left to right, slope downward, we would call that a negative correlation. And if they don't really have any kind of a pattern to them, like the one in the middle, we would call that no correlation. Okay. Now, the positive and negative correlations also have more specific descriptors. Like, for example, this first one, where they are very in a very tight line, almost a straight line, we would call that a strong positive correlation. Strong positive correlation. The next one, we would just describe that as a positive correlation. All right, and this one we would say is a weak positive correlation. Okay, so the closer the points are to a straight line, we say the stronger that positive correlation is. And then the less they are kind of fitting toward a straight line, in a straight line, the weaker we say the correlation is. All right, and if it's kind of too close to generally describe as a strong or a weak, you could just call it a positive correlation. Now, this one is clearly no correlation. All right, it doesn't tend to go upward or downward from left to right, so it's not a positive or a negative correlation. And just like we had with the positive, three different types of positive correlations, we've got three different types of negative correlations. We'll call this one weak, negative. This data has a weak negative correlation. We'll just call this a negative correlation. It really doesn't necessarily fall in the category of strong or weak, or it could be described as either one. It's, in other words, too close to call on one or the other. And this one is almost in a straight line, so we would definitely call this a strong negative correlation. All right, so when we have scatter plot data, we can describe them as strong, weak, or no correlation, and then we can get more specific to say what type of positive correlation or what type of negative correlation that the data has. All right. Now, the next subject that we kind of get into is the subject of causation. In other words, does the association that we have, does it represent a causation? In other words, does one set of data, the way it correlates to the other one, would you say that it's a causation relationship? Like one going up or down causes the other one to go up and down. And here's what we mean. Let's read the first one. It rains all day and the lake water level rises. Okay, we would say that does have a causation. All right. Okay, because raining all day will directly cause the water level in the lake to rise. All right, so we'll say that this association does represent a causation because this will cause this. All right, direct causation. What about the next one though? Let's think about that. Okay, it says ice cream sales increase and the weather gets hotter. Okay. Now, you have to be careful and make sure that you understand which one is listed first here. Okay? All right. If the ice cream sales go up, more people buy ice cream, will that automatically cause the weather to get hotter? I'm going to say no on that. No causation. Okay? Because if a bunch of people decide in January that they want to buy ice cream all of a sudden, that's not going to cause the weather to get hotter in the middle of the wintertime. Okay, so no causation there. Now you could make an argument that if it was the other way around, maybe if it's hot outside, more people want to buy ice cream. But definitely no causation with the way it's listed here. Okay, the amount of ice cream sold has no effect on what the weather does whatsoever. There is no causation here at all. Okay, what about the next one? The time on a cell phone and the remaining battery life. All right, the more you talk on the cell phone, the less remaining battery life you're going to have. That is causation. And I would say that would probably be a negative correlation. The higher the minutes go talking on the cell phone, all right, the less amount of battery life you're going to have remaining. As one goes up, the other one goes down, negative correlation. All right. Let's see here. What else do we have? Okay, the next thing that we want to look at here is it says the following graphs represent the weight of a panda versus the age in months. So the weight of the panda and then the number of months, how old the panda is. Tell the association represented and if there is a causation. All right, so the association that is represented here, right, is going to be, we could say that if we wanted to describe the correlation that's represented with this data, we would call it a positive correlation. Okay, and is there any causation here? All right, so the older the panda gets, then the more weight it's going to put on because the bigger it's going to be. So there is causation. Okay, so there is causation represented here. Okay, now predict how much the panda weighs at 8 months. So if we were looking along this and just kind of generally seeing the way the data tends to go here on this one, right? If we were to look here at 8 months, where do you think the dot would be for the data? All right, so I would venture to say that it would probably be around here somewhere, all right, if I were looking to see where it would fall. And I would say if I wanted to predict how much the panda weighs at 8 months, I would say at 8 months he's probably going to weigh 70 pounds or somewhere pretty close to that. All right, so I would say that's a pretty good prediction. Okay, now predict how old the panda was when he weighed 10 pounds. Okay, so if we wanted to predict how old the panda was when he weighed 10 pounds, okay, so 10 is here, and if I start kind of drawing a line back here, then I'm going to say that he was probably 0 months old when he weighed 10 pounds. So I would say he was probably born weighing at least 10 pounds, all right? Just because of the general way that the line is moving, right? So that's how you would go through and answer these types of questions, and based on these examples, then you should be now prepared to go do your quiz in Canvas.